Hi, welcome to another chemistry video. Today we're going to be learning about how to actually calculate Kc value whenever concentration is actually obtainable from the question. So what happened is that obviously you can see the reaction we're looking at is actually based on A plus B. You're going to get C and D. Of course, this is just examples, right, using the alphabets over here. Now the questions actually gave us the number moles of the reactants of A and B. It also actually gives us the equilibrium number of moles of C. So based on this information given to us, we are required to actually calculate the equilibrium constant, which is the Kc for this particular reaction. Now, what's given to us here in the question is also the volume, okay, of this particular mixture is actually going to be 1 decimeter cube. It's going to be important. We're going to use it later. So obviously, before calculating Kc itself, you need to actually prepare your I.C.E table to enable you to calculate the equilibrium number of moles of the reactants and also the product. So if you have not watched the video on how to actually create your own I.C.E table to find out the number of moles of the equilibrium of both reactants and product, please click on the link right above right now. Okay, so now this particular video, it's actually just going to be focusing mainly on calculating Kc value. So I'm just going to be tabulating the data over here. All the equilibrium number of moles of my reactants is actually given here, and then equilibrium number of moles of my products are also given as in the I.C.E table. So what we're going to be doing next is that obviously we now need to calculate our Kc value. So before we move on to calculate the Kc value, we need to actually look at how to make our own expression. So this is actually our Kc expression. Now remember, for writing Kc expression, you always need to put up the concentration of the product, right? You multiply them together. Whenever there is a number of moles given in front of the product, you actually power the concentration of that product by the number of moles given in the stoichiometry equation. And of course, the one in the denominator, you actually have to put a concentration of the reactants. Okay, again, the same thing again. If you got more than 1 moles, please make sure you power the concentration of the reactant by the number of moles that you see in the stoichiometry equation. Another important note here is that make sure you exclude all solids from your Kc expression. Same goes to the Kp expression as well. Whenever you see solid, please exclude them. You omit them from the Kc or Kp expression. So this is our Kc expression. Now notice that all these are actually in concentration term. Square bracket, by the way, represents concentration. Now all these are actually concentration. And on our I.C.E table, what you notice is that all this is actually given in moles. All these are actually given in moles. So there is one extra step that you actually need to do in order for you to actually calculate our Kc. Yes, based on the moles that we actually obtained, we actually need now to put in our number of moles, okay, and the volume together in order for us to work out the concentration. Remember, yeah, concentration is basically mole over the volume. So since the mole is actually found on the I.C.E table, all we have to do is just divide with the volume that is actually given to us. Volume given to us in the question is actually 1 decimeter cube. So basically just use that particular value, right, to represent the volume, okay, in the calculation of the concentration. Remember again, I repeat, mole over volume is actually concentration. So in the question, there should be volume given to you. Now, volume given in this question is 1 decimeter cube. In other questions, the volume could be different. It could give you, like, for example, 2 decimeter cube, 2.5 decimeter cube. It all depends, right? So you just have to be careful. Make sure your mole is actually divided with the volume in order to actually have the concentration over here, right, for C. Right, and of course, the same thing you do at 0.15 is basically the number of moles of your D divide with the volume. Okay, don't forget the power by 3 because there are actually 3 moles of D on the product side. And of course, the same thing is actually done on the reactants. Okay, that's basically what you need to do. And then of course, right, very important, just punch in the values in the calculator and then you should be able to get the answer over here. The answer turns out to be 0.0211 a mole per decimeter cube. The unit here is mole per decimeter cube because on the top, on the numerator, there are basically 4 concentration terms. At the bottom, there's only 3 concentration terms. So if you actually cancel them off, you're going to left with just 1 concentration term remaining on this particular Kc value for this particular reaction. Okay, right? So yeah, that's about it for this particular video, right? So just be careful. Just a reminder once again, you are actually needing the concentration whenever you are actually calculating the KC value. So be sure to make sure you actually put up all the concentration of the products and the reactants whenever you are doing KC calculation. All right, so with that, that's the end of the video for today, right? So if you are wanting to look at how to calculate the KP value, please click on the link given right above right now, right? Okay, yep, the link should be up there, right? So my name is Lucas Chan. Thank you very much. I'll see you in the next one. Thank you. Bye.